All right, let's look at the homework 2.2, problem number 10. All right, so we're gonna try to, I guess we're trying to find the derivative of this function, cube root of x. All right, so click here to begin. All right, so we're taking a derivative of f and evaluate it at a. So we're using this definition here. All right, then we have, we just rewrote cube root as 1/3 power minus a to the 1/3 power. That's easy enough. And here, they're using this trick. So if you multiply this numerator by this guy, we can actually make x minus a. So let's do that too on top and on the bottom. So on top it becomes, let's see, we multiply by, actually, let's see, they actually factored out, okay, sorry, it's slightly different. They factored out x minus a into this form, so they rewrote it this way, all right? Then we cancel those out. So what's left is going to be on top is going, since we cancel out, so it's going to be just 1, right? Then you can submit. All right, looks like we got this one correctly. All right, now we can evaluate the limit by sending x to a. All right, so x becomes a. So you have a to the 2/3 power. It's going to be a to the 1/3 times a to the 1/3 is going to be combined a to the 2/3 power. And you have a to the 2/3 power. So you have 3 of them. So it's going to be 1 over, right, 3 a to the 2/3 power. All right, let's submit. All right, it came back. It looks like we got this one correctly. All right, then we're gonna start exercise B. So I'm gonna click here to begin. All right, so we're looking at, let's see, we want to show that f prime of 0 does not exist. All right, so just put, 0 for x here. So we have f of 0 plus h minus f of 0 over h. So that's just a definition here. All right, f of 0 plus h, which is the same thing as f of h. So we will have h to the, so it's a cube root, right? So it's h to the 1/3 power, right? Minus 0, cube root of 0 is 0, so I'm not going to write that down, right? Then if you simplify here, right? So if you have h to the 1 on the bottom and you have h to the 1/3 power, so we can subtract 1 from 1/3. So you have h to the 2/3 power, right? We have that, and we have to submit. Let's submit. All right, it came back and looks like we got these guys correctly. And I'm gonna look at this guy. All right, it says that as h approaches 0, 1 over, or actually this is right here, 2/3 power is going to go to, let's see, so it's, as this guy shrinks to 0, it's 0, but then there is a square here, so we know that it's always positive. So 1 divided by positive infinity is going to be, positive 0 would be positive infinity. So I'll just say infinity here. All right, let's submit. All right, it came back and looks like we got this one correctly as well. Then this is, I believe, the last part, C, and click here to begin. All right, so let's say in a previous part we found that f prime of x is 1 over 3x to the 2/3 power. As x approaches 0, this quantity goes to positive infinity, right? So we did that. Since f prime gives the slope of the tangent line x, we conclude that the tangent line at the 0, 0 for this guy is vertical, right? Then submit. All right, it came back and we got these guys correctly as well. I think that's all we have to do this problem. All right, that's it. I hope that this was clear.